Hi! We are the Facers from the Technological Institute of the Philippines. We are the students enrolled in Digital Communications course.
Our problem is to generate a 16 PSK modulator using the add-on product of MATLAB, which is the Simulink.
First, let us have a quick talk about Simulink. Simulink is a visual tool for creating computational simulations. Students like us love Simulink. It is because of its drag-and-drop system for simulation using simple blocks and lines. We are able to create an up-and-running model that would otherwise require hours to build in a normal laboratory setup.
Moving on, phase shift keying or PSK is a method of digital communication in which the phase of a transmitted signal is varied to convey information, with the amplitude and frequency being constant. A more sophisticated form of PSK, which is the MR phase shift keying or MPSK, exists. In this project, the 16 PSK was demonstrated.
In a 16 PSK, there are 16 phases, and each phase shift represents 4 signal elements. The first block is the random integer block, which generates uniformly distributed random integers or the TTL message signal. In this case, the set size was set to 16.
The output from the random integer was fed to the MPSK modulator baseband block. This resembled to a built-in 16 PSK modulator that instantly generates a constellation diagram from the predefined inputs.
In here, the M-ARRY number is set to 16 to indicate that there are 16 levels to be used in this simulation.
The constellation block simply displays the constellation diagram of the 16 PSK. As can be seen from the generated output, 16 dots are generated, each of which carries a different phase from the other.
The output of the 16 PSK modulator was again used and fed to the complex to real imaginary block, which outputs the real and imaginary components of the input. Thus, it generates an output of I and Q separated, given that I is the real component and Q is the imaginary component.
For the simulation, the sine wave block was used to generate the sinusoidal carrier signal. This was multiplied to the I component. The sine wave block was also used to generate the sinusoidal carrier signal with a 90-degree phase shift, which is equivalent to the cosine wave, which was then multiplied to the Q component. For the multiplication, the product block was used.
Finally, a linear summer was used to perform the summation of the two balanced modulator outputs. The output signal was viewed using the scope block.
We conclude that it is possible to generate the waveform and the constellation diagram of a 16 PSK modulator.
Thank you for listening. Once again, we are the Facers.